Hi guys, welcome back. Today we'll be doing question 4. Starting off with question 4.1.1, it says consider the function f of x. Calculate the coordinates of the y-intercept of the graph of f. Okay, whenever we ask for x or y-intercepts, we're just going to make the other variable equal to 0. So in this case here, for y-intercept, let x equal to 0. Okay. Okay, so we're just going to let x equal to 0 and leaving everything else the same. And we get the answer of negative 3. So it would be 0 and negative 3. 4.1.2 states calculate the coordinates of the x-intercept of the graph. Okay, so for x-intercept, let y equal to 0. 0 is equal to 3 to the power of x minus 6. 6 is equal to 3 to the power 2 to the power of x. Dividing both sides by 3, we get 2 is equal to 2 to the power of x. We know that this 2 is to the power of 1. Whenever we have two bases that are the same, we can drop the base. Therefore, the exponent is equal to 1. The coordinate is 1 and 0. 4.1.3 says sketch the graph of f in your answer book. Of course, we don't have an answer book, so we'll just draw a rough sketch of a Cartesian plane. Okay, how do we know what to plot in this instance? We know that the graph has an asymptote, and this asymptote is negative 6. So we're going to put in our asymptote at negative 6. Okay, we know it's a y asymptote because it's not attached to x in any way. So y is equal to negative 6. We're going to label our axes. Then we're going to put in our x and y intercepts. The first one would be the y-intercept at negative 3, so around there. And for x at around 1. Okay, so starting off from the left of the graph, we know that the graph must come as close as possible to the asymptote, but not touching it. So starting off very close and gradually going up, going through both intercepts. Okay, labeling the graph of f. 4.1.4 says write down the range of f. Okay, range is from top to bottom or bottom to top, and in this case here we have an asymptote at negative 6 and the graph falls above the asymptote. Therefore, everything below the asymptote will never be included in this graph. The graph will never be in that side of the asymptote. So the graph will only form when y is greater than negative 6. Moving on to question 4.2, it says s is the coordinate negative 2 and 0, and t, 6 and 0 are the x-intercepts of the graph of f of x, and r is the y-intercept. The straight line through r and t represents the graph of g of x is equal to negative 2x plus d. Determine the value of d. Okay, in this case here, d is the y-intercept of the graph. Okay, so looking at it, we can go and substitute the values that we know already. Let's rewrite this one here as 4.2.1, and we know the equation of this graph is g of x is equal to negative 2x plus d, with d being the only missing value. Okay, so all we have to do is find a value, a coordinate to go within this, and we already have one coordinate because it's t. T is common to both graphs f and g. Okay, so 0 is equal to negative 2 into 6 plus d. Therefore, d is equal to 12. 4.2.2 says determine the equation of f in the form f of x is equal to ax squared plus bx plus c. So 4.2.2. We can start off with the intercepts. Because we know the intercepts, we can use the formula y is equal to a into x minus x1 to x minus x2. Okay, so all we need is the two x-intercepts and another coordinate. Do we have that other coordinate? Yes, we do. What is that coordinate? It is r. Okay, so in this case here we have 12, because that's the coordinate of r. So 12 into a, which we are trying to solve for. So it's a into, and then 0 minus 6 into 0 plus 2, because it's 0 minus minus 2, which gives us that positive 2. Solving for a, we get a is equal to negative 1. Okay, from here you can go and just substitute a back in, so we can say y is equal to negative 1 x minus 6 into x plus 2, and foiling this out, we can get the equation y is equal to negative x squared plus 4x plus 12. Okay, 4.2.3 states that if f of x is equal to negative x squared plus 4x plus 12, calculate the coordinates of the turning point of f. Okay, how do we determine the turning point of a graph? We can use the equation x is equal to negative b all over 2a. Okay, b is the 4, so negative 4 all over 2 into negative 1, and we get the x coordinate to come to 2. Okay, how do we solve for the y? We just simply put it back in the equation. So y is equal to negative into 2, let's go ahead and write that, into 2 squared plus 4 into 2 plus 12, and we get the y to equal to 16. Okay, therefore the coordinates of the turning point would be 2 and 16. Of course, once you've done calculus, you'll be able to come back here and figure this question out with first derivatives. Okay, moving on to question 4.2.4. For which values of k will f of x is equal to k have two distinct roots? Okay, so this is an interesting question. It's saying for which values of k will the graph which is equal to k have two distinct roots. Two distinct roots is basically saying where will it have two different x-intercepts. Okay, so if we look at the graph, and we can see that it has x-intercepts at negative 2 and positive 6. Okay, so it will continuously have x-intercepts like these if we move the graph upwards, because as we move the graph upwards, the x Cartesian line would move there and there and there, and so on and so on and so on, and we can see that it will continuously have x-intercepts if we move it down. But if we choose to move the x line upwards, we can see that at this point it does have two x-intercepts. At this point it has two x-intercepts there and there. Same here, two x-intercepts. But once we move it to the turning point, it will only have one x-intercept. Okay, so at this point here, it no longer has two distinct roots and therefore does not fall part of the question. So we have to move it in a certain way between where it is now to the turning point for it to have this distinct turning points. Okay, so it's between negative infinity because it's moving from down. So it's moving from a lower one, so negative infinity, because it can always have, it will always have at the bottom, so negative infinity, and the x Cartesian plane cannot be above this point here. Okay, so it cannot be above the turning point, and we know that the turning point is at 16. Okay, here's it here, 16. Okay, another way to write this is you could say when k is less than 16. I hope that makes sense. 4.2.5. Determine the maximum value of h of x is equal to 3 to the power f of x minus 12. Okay, so in this case here, what we're going to do is they're asking for a maximum value. Okay, so f of x is referring to the previous graph, which is negative x squared plus 4x plus 12. and they're asking for a maximum value. Okay, so what is the maximum value for the graph of f of x? Okay, so let's deal with that first. The maximum value of any graph would be the turning point, especially for a parabola, it would be the turning point. And what is the maximum value of the turning point of this parabola? It would be here at this point here, at the top of the graph, which is 16. Okay, so the coordinate is 2 and 16, but we are more interested in the y coordinate, which is 16 there. Okay, so if we have to rewrite it, h of x is equal to 3, we'll go f of x minus 12. So they ask for the maximum value. So first we'll deal with the f of x part, which is in the exponent. The maximum value of that graph, of the f of x graph, is at 16. Okay, so minus 12. So we get 3 to the power of 4, which is equal to 81. Okay, so that's the way you solve that question.